Okay, welcome back to part 2 for this percent composition. Now that we know how to do that, we're going to take this one step further and put it into empirical and molecular formulas of a compound. So let's get started with that. Okay, so the first thing that we need to understand are there's two different types of formulas. The first one is called an empirical formula, and what that means is it's the lowest whole number ratio of a compound. So if I gave you an example of, let's say, some sugar, which would be, let's say, oops, let me get a color here, C6H12O6. This is what we would call its molecular formula because we can individually determine how many atoms of each one of these elements there are. Okay, but if we were to do a whole number ratio, we would divide everything here by 6, and notice how we would get C, that would be a 1, H, and that would divide to 2, and this would divide to 1. Okay, so this is what we call the empirical formula for sugars. Now, each sugar, of course, will have its own amount of these atoms over here. Glucose will be different than fructose, which will be different than galactose, but they will all have this empirical formula, lowest whole number ratio. Okay, so let's find out how to solve these. The first thing that we want to do is determine the mass of an element and get it into moles. So yes, you're going to need your molar mass in your periodic table for these. So sometimes you will be given a percent, not to worry. If we're given 96% like composition, what we were doing earlier, what we can do is assume that that's 96 parts per 100. So we can assume a 100 gram sample, and so this will easily convert into 96 grams. So if you have a percentage, simply make it into grams. Okay, once you have your grams, you're going to go to step 2, which is convert the mass to moles. So if I, let's just say, had 96 grams of oxygen, then I would get my molar mass, which is 16 grams per mole. Use your periodic table for this, okay? And then we would determine how many moles there were here. Okay, step 3, whenever you're doing these, you're going to divide all molar amounts by the smallest molar amount. And then once you divide by that, whatever that number is going to be the number that's found for each subscript of the element. And I'll show you what I mean by that in a minute. Sometimes you're going to have wacky numbers like 1.5, and we don't like those, so just simply force that into a whole number ratio. So if you have 1.5, just multiply it by 2 and get 3. And I'll show you an example of that in a little bit. Okay, but for now, let's give an example of some lead oxide. Okay, right here we have a problem, and I have this kind of pre-done over here so that I have the math figured out. So I'll need to keep consulting my periodic table. Okay, well, anyway, so we have 2.765 grams, and that was of lead oxide. That's the entire compound lead oxide. So what we need to do is find out whenever this was converted to elemental lead, that's how much that we had left, which is great. Okay, but we need to find out what would happen to oxygen. So to do this, we can simply do a quick math problem where we would take 2.765 of the entire sample of lead oxide, subtract to that just the lead, which is 2.401, and that'll let us know how much oxygen that we have left here. Okay, so once we figure out how much that is, now we can take, and this is in grams, and now we can take that and find moles, and this is also in grams. Okay, so let's go and do this. We're going to go find moles of lead. We have 2.401 grams. And let's see here, let's go look at lead on the periodic table. And we have 207.2, 0.02, yeah, 0.2 grams per mole. Okay, let's do the same thing, and then this comes out to be, let's go look on our calculator here. So we have 2.401 divided by 207.2, that comes out to be 0.116. Okay, so now we have this one in grams, which is 0.34364 grams. of oxygen. And there's 16 grams per mole. Okay, let's go and solve this. 0.364 divided by 16. We get 0.0228. Okay, now step 3 back here said to divide all molar amounts by the smallest molar amounts. And then whenever we determine that number, that'll be the subscript that we place. So let's go and determine which one of these is the smallest. Well, hopefully you have figured out that it's this one that's the smallest. So I'm going to go clean this up and put this down here just so it looks a little bit better. 116. This is 0.0228. Okay, I'm going to divide both of them by the lowest number. This is going to come out to be 1, and this is going to approximately come out to be 2. It's like 1.96. We just rounded up to 2. So that means that we have 1 lead. That signifies the subscript for lead, and this signifies the subscript for oxygen. So our empirical formula for this actual problem is PbO2. Okay, they're not too bad. Now let's go look at the molecular formula. That means the actual number of atoms in the molecule. So there's 2 steps that you have to do here. First of all, you have to determine the empirical formula. And the second step is you have a little formula that you have to solve. You take whatever the molecular mass is that they give you in the problem, and then you put that over the empirical mass that you just found out up in this step. Okay? And then once you get that number, that will be what gets multiplied by the empirical formula and the subscripts later on. And I'll explain that in 1 minute. So let's just go and look at an actual problem, and sometimes working these helps. Okay, so the first thing we have here, remember we said we could take these percentages and make them into mass. So we have 71.65, we're going to turn that into grams, okay? And then we have 35.5 grams per mole, and it comes out to be 2.02 moles. Okay, same thing with this one, 24.27. We're going to turn that into grams, and there's 12.01 grams per mole, and that comes out to be, I think, 2.03, or somewhere in the area. Okay, this one, 4.07 grams of hydrogen, and we have 1.01 grams per mole. Comes out to be about 4.03. Okay, so which one is the smallest here? Well, hopefully you determined it was this one. So we're going to multiply each one by this. This comes out to be 2, this comes out to be 1, and this comes out to be 1. Okay, so our empirical formula is, I'm going to put this in order of electronegativity, this one being the least electronegative, which is H2CCl. Okay, so that's the empirical formula. Now, this one here said that we want to find the molecular formula, and we just determined that it's this formula over here, the molecular over the empirical. They gave us the molecular mass, so that goes on top, 98.96, and we have to find the empirical. Okay, so let's go and do that. Well, we know that if there's 2 H's, that's 1.01 times 2. I'm just using my periodic table here. Add to that 12.01 for the carbon and 35.5 for the chlorine. Let's go and do that here. $49.53. Okay, so it's 49.53. Put that over here, 49.53. Comes out to be approximately 2. Now we take this number with our molecular formula and we stick it up here and multiply each subscript from the empirical formula by this number. So this is what we get now. We have H4C2Cl2. That's the amount of atoms in this actual compound, okay? And this is actually Freon. Alrighty, So these aren't too bad. Let's go and work maybe a couple more problems. I do have a worksheet for you in class that you're going to do, and I did the answer key so you can check your answers in the back when you're done. And then we will be following up this exercise with a lab with magnesium and oxygen, which we will meet next time in the laboratory after we do these problems here. So let's just do one or two more problems. This one's asking for the empirical formula. We were given some percent compositions, no big deal. We just take our chromium and just make that into a mass. Okay, I have to go look up chromium on the periodic table here. Let me go get that real quick. Go hunt for it. (52 grams per mole). This comes out to be 1.315. Okay, now let's go look at oxygen. Oxygen, they give us 31.6%. We're going to make that grams. This comes out to be 1.975. Okay, so moles. Don't forget we want to divide now by the lowest number out of these two, which is this one, 1.315. It comes out to be 1. So far we know that we have chromium 1. I'm not going to put that though. And then we do this 1.315, and this comes out to be approximately 1.5. Remember, we don't like that, okay? It looks weird. So what we need to do, sorry, I'm going to get rid of that here, is multiply this entire thing by 2, and you end up with Cr2O3. That's the correct molecular formula. Okay, so these aren't too hard. Just make sure that you know, this is the right empirical formula for this one. If we were to ask for the molecular formula, then it would give us a molecular mass, in which case we would find the empirical mass and put the molecular over empirical to find out what that number is to multiply by each one of these. But it didn't ask us for that, so we're good with the empirical formula. Okay, let's do one now that's asking for both. We're going to start from the beginning and move all the way through. So here we have 5.92 grams of hydrogen, and that's times 1.01 grams per mole. This is hydrogen, and then we're going to go look at oxygen, which is 94.07 grams, 16 grams per mole. And see, I think I have this worked out somewhere. 5.87, and then this comes out to be 5.88. So they're in a 1-to-1 ratio. You can see that already. Okay. So our empirical formula is HO. Okay, now it wants us to also determine the molecular formula. No problem. It gave us the molecular mass, so we could start with that. We put that 34.014 grams per mole, and we have to determine the empirical formula, which is easy. 16 plus 1 is 17. 17.01 if you want to be exact. I'm putting this grams per mole. Notice how this entire unit will cancel out, leaving us with a whole number. Okay, which is going to be approximately 2. If you remember, you take this number and then you multiply it by each of the existing subscripts. So our molecular formula is going to be H2O2. Okay, whole number ratio, exact amount of atoms per element. All right, so these aren't too bad. Again, keep working some of these. Make sure you get a good handle of them, and I will see you in class soon.